Today we are going to use trig identities to find the value of some trig functions, alright, given one value. This is the number one most fundamental identity. Sine squared theta plus cosine squared theta equals 1. Please understand that when we write sine squared theta, it's the same thing as having sine theta squared, but it becomes much more convenient to write it this way. So get comfortable with the fact that sine theta squared, we're going to write it as sine squared theta from now on. It will avoid having too many parentheses. It's just cleaner. Commit this to memory immediately. This is going to come up over and over again throughout the unit. Now, this basic identity will quickly give us two other identities that are not so important to memorize because of how quickly you can find them. Basically, if we divide everything by sine squared theta, watch what happens. Well, anything divided by itself is 1, so I'm going to get 1 right there. Cosine over sine. Remember that sine over cosine is tangent? Well, cosine over sine will be cotangent, so this would be cotangent squared theta. And this is another reciprocal trig function because 1 over sine is the cosecant. So this would be the same thing as cosecant squared theta. Okay, so this white identity is another identity that we can use. But if you don't memorize it, you can quickly just divide everything by sine theta and come up with it. Alright, now I'm going to put that aside for the moment and go back. So, if we divide everything by sine squared theta, we get this. What if we divide everything by cosine squared theta instead? Let's see what that would look like. If I divide by cosine squared theta, okay, now what am I going to get? Sine over cosine is tangent, so this would be tangent squared theta. Anything divided by itself is 1, so that'll be 1. And 1 over cosine, well, that's secant. So this would be secant squared theta. So definitely memorize the yellow one. Okay, that's the parent one. Sine squared theta plus cosine squared theta equals 1. Lock that in. But if we divide by sine, we get this one. If we divide by cosine squared theta, we get this one. So we're going to need all three. Now, the way this is going to come up is because looking at the yellow one, we have sine theta and cosine theta and then 1. So if we know sine theta, we could plug that in and solve for cosine theta. If we know cosine, we can plug that in and solve for sine. So using this, basically if we know one function, we can find the other automatically with a little bit of algebra. So sine and cosine are connected from now on for us. So if I want to find secant theta, first I need to just remember that this is 1 over the cosine theta. So there's that cosine. So like I said, if I have sine, I can get cosine using this identity. So let's try that out. So just writing down the identity. So we have sine squared theta plus cosine squared theta is equal to 1. Now we know that sine theta is 1/2. So I'm going to take that and substitute it in right here. Okay, so this is going to become, so remember, this is, just one more time, having sine squared theta is like having sine theta squared. Alright, these two things mean the same thing. But sine theta equals 1/2. So this is 1/2 squared, okay? Plus cosine squared theta is equal to 1. So I want to find secant, so all I really have to do is find cosine and then do the reciprocal, turn it upside down. So here I go. If I square this, I'm going to get 1/4. Okay, 1 squared and 2 squared. So now I've got 1/4 plus cosine squared theta is equal to 1. So time to subtract 1/4 from both sides. Minus 1/4 minus 1/4. Okay, so that's going to give me cosine squared theta is equal to, now 1 whole minus 1/4 is 3/4. Alright, if you can't do that in your head the way I did, then you have to do the whole like denominator thing. Now 1 is going to show up so often that I want you to get comfortable with the following. 1 is a chameleon. Because anything divided by itself is 1, if I see the number 1, I know I can write it any way I want to. Okay, if I've got the number 1, I could write that as 5/5, or 6/6, or 4/4. I can write that as anything over itself. I could go pi/pi if I wanted to. Okay, so 1 is a chameleon like that. So if I want a denominator 4, I don't think about it too hard. I immediately go to 4/4 with it. Okay, so when I see 1 minus 1/4, then I'm thinking, alright, well that's 4/4 minus 1/4. Alright, so that's why it's going to be 3/4. So I want cosine, just plain cosine. So I need to take the square root of both sides to unsquare this. Don't forget, if you take the square root of both sides, it will be plus or minus. Alright, so that's going to give us cosine theta, alright, we unsquared it, is equal to plus or minus. I'm taking the square root of the top and bottom. In the top I've got square root of 3, square root of 4 is 2. Alright, so it's square root of 3/2. Now, this information right here is giving us the quadrant. Alright, between 90 and 180, do you understand that if this is my circle, 90 degrees is here, 180 is here. So between 90 and 180, that's the second quadrant. I'm mentioning that because now we can decide, is it positive or negative? Well, is cosine positive or negative in this quadrant? It'll be negative because cosine is x values on the unit circle, and x values are negative over here to the left. So we can dispense with the plus or minus based on that and go with the minus. So in the end, though, we wanted the secant theta. So secant theta is going to be the reciprocal of this. So that would be -2 over radical 3. So that would be our final answer. Some people like to rationalize this, so I'll just mention it real quick. If I have 2 over radical 3, the way you would rationalize that is to multiply by radical 3 in the top and the bottom. Alright, that would give us 2 radical 3 over 3. Okay, so a lot of people will write, instead of 2 over radical 3, they would write 2 radical 3 over 3. So just be comfortable with that. Alright, let's look at one more example on this video. Let's take a look at number 2. Now, we're dealing with tangent now. So look back at your 3 Pythagorean identities. See how the middle one involves tangent? So let's look at that. Tangent squared theta plus 1 is equal to secant squared theta. Okay, so tangent squared theta plus 1 is equal to secant squared theta. Alright, and then they're asking us for cosine, and this will be useful because we know that cosine, of course, is 1 over secant. Alright, so if we find secant, we can find cosine just by doing the reciprocal. So let's use this connection because we have a link between tangent and secant. If we have one, we can find the other. That's the way these work. Alright, this is a connection between cotangent and cosecant. If I find one, then I find the other. Alright, so I have tangent. So I can do the substitution. So this is really going to be 1/7 squared, alright, because that's tangent squared is 1/7 squared, plus 1 is equal to secant squared theta. Well, this would be 1 over 49. Now remember that 1 is a chameleon. I need a denominator 49, so just go straight to this. 49 over 49, okay, equals 1. So that's secant squared theta. So that's going to be 50 over 49, right? So I've got 50 over 49 is equal to secant squared theta. Now I need just plain secant, so I'm going to take the square root of both sides. Square root, square root. Don't forget the solution will be positive or negative when you take the square root of both sides. Alright, the quadrant will let us know which one it is in a moment. But for now, let's write that secant, okay, we've unsquared it now, is going to equal plus or minus, and we've got the square root of 50 over 7. Square root of 50, we need to simplify that. Alright, square root of 50, you know that that is 25 times 2, right? For that reason, this will simplify, and the radical 2 is going to have to stay inside. But the square root of 25 is 5, so that's 5 radical 2. Alright, so this is going to be the same thing as secant theta is plus or minus 5 radical 2 over 7. But we wanted the cosine, so that's going to be the reciprocal of this. Alright, so cosine is going to be plus or minus 7 over 5 radical 2. Okay, and you might be wanting to rationalize the denominator. I kind of feel like rationalizing the denominator. So I'm going to multiply each of these by radical 2. So that's going to give me cosine theta is equal to plus or minus 7 radical 2 over, now I've got 5 times 2, so that's plus or minus 7 radical 2 over 10. Now, is it plus or minus? Well, let's look at our diagram of a unit circle. And it says between 0 and pi over 2. Of course, 0 is here, pi over 2 is here. So we are speaking of the first quadrant where cosine is certainly positive. So we'll use that information to get rid of the negative. Okay, so I'm just going to get this out of here actually. So that's it. So it'll be positive 7 radical 2 over 10. Alright, so that's long enough for one video. I feel like I need to point out one thing. We're asking you to use trig identities to do this time. But you might be thinking, wait a minute, didn't we solve problems like this before without using trig identities? So I feel like I should mention that, yeah, this problem should be looking real familiar to you. Here's a way we did it before, but please be sure to, we're practicing our trig identities. So the way I'm going to remind you of is not the way you should be doing it this time around. We've done that and learned that, and now we're learning something new. But if sine theta is equal to 1/2, here's what we used to do. Alright, in the previous little unit. We said to ourselves, okay, let's graph it. And they even told us a quadrant, so we know to graph it over here. So we would go like this, and we'd go into that quadrant and we'd make our triangle, remember? And we'd look at this reference angle. So if they're saying that the sine is 1/2, that's opposite over hypotenuse, right? So that would be 1/2, opposite over hypotenuse. A little Pythagorean theorem with the 1 squared plus x squared is equal to 2 squared, right? So that would be 1 plus x squared is equal to 4. Subtracting the 1 would give us x squared equals 3. Take the square root of both sides. That gives us x equals radical 3. So I'd have radical 3, and it would definitely be the negative version because we're over on the left over here with the x value. And then we could do any trig function we wanted, including secant, because we'd go, okay, secant is the reciprocal of the cosine function. Well, cosine, looking at our picture, cosine is adjacent over hypotenuse, so that would have been negative radical 3/2. So that means secant would equal the reciprocal of that, so that would be negative 2 over radical 3. Okay, and oh look, negative 2 over radical 3, that's the same thing we got by using these trig identities, but we already knew how to do it using a picture. So I thought I should mention that, but in this unit we're going to be using trig identities. So maybe you can use this to check your answers, check your work, if you have like time like that. But this is please use your trig identities. Alright, that's plenty for one video. I'll do more examples in future videos if you would like to see more problems worked out. I'll see you on the next video.